We have done this one. Thin client.
Uh,
Do you remember thin client?
yeah, I remember thin and thick.
Uh,
Yeah, I do.
Private network. Okay. Then public network. Thin client. Do you remember? There are two types of client: thin client
What?
and
Thick client.
thick client. Thin client means uh, client, I mean workstation will not have any processor and storage capacity. It will store its data on server,
Okay.
on remote computer, and processing also will be done on remote computer. Like say a thin client or
Okay, okay.
a lean client is a virtual desktop computing model that run on the resources stored on a central server instead of computer resources. But locally, it doesn't have any storage and processing power. The normal thin client takes the form of low-cost computing devices that have heavily rely on a server for computation. Computation will also perform on server. Here you can see there are different clients. They don't have any CPU. Okay. This client, this client, this client don't
Okay.
have any CPU and storage capacity.
Yeah.
All things will happen on server, processing and storage. Got it?
Yeah, okay.
Here you can see user, everything is accessing from server. It has only monitor and this device which connect with server. Okay.
Okay.
Now thick client in this environment, being a user, you will have a storage and CPU. Okay. So locally you can process and store data. A thick client is a form of client server architecture. Specifically, it is a networked computer system with most resources installed locally. So you have resources locally rather than distributed over network. Thin client. Essentially, any device that can function completely independently of remote server is a thick client. So you are not dependent on remote server to store data and process data. Okay, you got the point?
Yeah. Okay, okay.
Okay. So how many classes you have in school for computer?
Yeah.
How many classes are computer in a week in your school?
Uh, like, yeah, except of one day, I think.
Say it again.
Every day, every day.
Every day you have class.
Yeah.
Means you have 4 or 5 period in a week.
No, no, not 4 or 5. We have like double lessons. So on Sunday we have 2 lessons,
Okay.
and Monday 1 lesson, Tuesday 2 lessons, Wednesday
Five,
1 lesson,
6, and Thursday. Tomorrow is Thursday.
and on Thursday 2 lessons. Yeah,
Means eight,
tomorrow 2 lessons.
so eight classes in a week. Okay. How many students you have in class?
We have like 20, I think.
Okay. Okay. Here, I think you remember you have done this one. Pros and cons, thick client and thin client. Have you done before that?
Yeah, yeah, yeah. I remember this. I
Okay.
remember.
Means you have done this.
Can I go over? Can I
Yeah,
can I
you
go
can.
through it?
Okay. You
One
can go.
1 minute. Okay, okay. Okay, sir, I'm done.
Then now thin
Yeah,
client
we'll go
software
through it.
and thick client software.
Okay.
Yes, Sumar, have you done?
Yes, sir, now I am. I was just noting some down.
Okay.
I'm done, I'm done.
Okay, now topology. Topology means network arrangement. How computers are connected with each other. This is called network layout, architecture,
Yeah.
but we call it network topology. Or okay, basically, network topology is the arrangement of various elements, links, nodes of a computer network. So essentially, it is the topological structure of a network and may be depicted physically or logically. So in communication network, a topology is a usually schematic description of the arrangement of network, including its nodes and connecting lines. So there are two ways of defining network topology: the physical topology and the logical single topology. Signal topology. The physical topology of a network is the actual geometric layout of a system. So topology means how your computer are arranged, look like in a computer networks. So there are different topologies. You can see here. There are basic three topology. Number one is the bus topology. Second is star topology. And third is ring topology. These are the basic. Rest is extension of these topology, like tree topology, batch topology, fully connected, line topology. So this is bus topology. So we'll discuss one by one. In bus topology, basically, there is a single cable, alternatively referred to as a line topology. A bus topology is a network setup in which each computer and network device are connected to a single cable or backbone. See the backs previous slide. Here you can see there is only single cable through which all computer connected with each other. Got the point?
Oh, yeah. Okay.
Okay.
Hello.
Yeah. Further detail are given. The first is information
Yes.
sent from a node. Node means computer, okay? Travel along the backbone. Backbone means single cable, okay? It has only single cable, we call it backbone, until it reaches its destination node. So it means, I go back. Now this computer is send data. It will travel on a cable. Travel until destination computer copy its data. So it will travel over the backbone. This cable is called backbone because it has only one cable. So each end of bus network must be terminated. Cable must have a terminator which can bounce the signal with a resistor to keep the signal that is sent by a node across the network from bouncing back when it reaches the end of the cable. Okay. In a bus network, every station receives all network traffic. So every station will receive the data. It will compare its address. If address is matches, then it will copy. Otherwise, it will ignore. And the traffic generated by each station has equal transmission priority. Every computer has equal transmission priority. But the problem is that only one computer can send data at a time. Who has access? A bus network forms a single network segment and collision domain, because if two PC or two computers send data at a time, then there will be a collide because it has only single path to transmit the data. And other PC or other computer has to wait to clear the path. In order for node to transmit on the same bus simultaneously, they use the media access control technology such as carriers and multiple access. So carrier means media on which data travel. Okay. And sense means this before sending data over network, they sense traffic network path available or not. If it is available, it starts sending. If not available, then they have to wait. If any link or segment of bus is disengaged, all network transmission ceases due to signal bounce caused by the lack of terminating resistor. Means if any computer connection is loose, like this one. If this computer connection is loose, so it means other data will not travel on the cable. Okay. So you have to identify connect.
Okay.
All connector are fixed with the cable. Or any computer is out of order, so data will not move on cable. This kind of network has finished. Okay. But device to device connectivity remains. That is called bus. Here you can see. If this PC data center, it will travel on the cable. These are terminator. These are terminator which make sure data should travel on a cable. It should not pass the cable. Because if there is no terminator, data will pass on. It will not bounce back. If it is not bounce back, then other PC, other computer could not access the data. Because every computer has to check whether their data or not. If address is matched, then they copies. Okay.
Okay.
Got it?
Okay.
Now this is the technology. Carrier sense multiple access, which will have all computer in their LAN card. It means a computer will sense before sending data. So this technology is called carrier sense multiple access. Because in bus topology there is issue. Multiple computer at a time could not send data. They have to wait their turn. So multiple access means that multiple nodes may send and receive on the medium. Transmission by one node are generally received by all other nodes connected to the medium. That means if one computer send data, other will receive, but they will not copy until their address match. CSMA is a MAC protocol in which a node verifies the absence of other traffic. CSMA is a MAC protocol in which a node verifies the absence of other traffic before transmitting on a shared transmission medium, such as electrical bus. So here you can see if this PC try to send data, that before sending it has to send, because this PC might have sent data before that. If data is on the cable, other PC has to wait to clear the network path. Okay, got the point?
Yeah, okay.
Okay. Now further detail, a transmitter attempt. Transmitter is a computer which transmits the data to determine, means sender, to determine whether another transmission is in progress before initiating a transmission. Okay. As I already told you, every computer try to sense before sending data. Network path available on. It try to detect the presence of carrier wave from another node before attempting to transfer. So it would try to sense if is there any other piece computer which has sent the data. If a carrier is sensed, the node waits for the transmission in progress to end before initiating its own transmission. So the computer has to wait until network path becomes free. So in other words, CSM is based on the principle sense before transmit or listen before talk. Another technology is given, CSMSED, collision detection. Collision detection. CSMA-CD is used to improve CSMA performance by terminating transmission as soon as a collision is detected, thus shortening the time required before a retry can be attempted. Got that? You can go through first.
Yeah, okay.
Just go through.
Okay, okay.
Coming in 1 minute. Okay. Yes, Umar. Have you gone through?
Yes.
Now here, another technology is given, CSMA-CD. So in this, basically, it is a complete technology. Now, carrier sense multiple access and collision detection. So if there is a network jam, other computer can detect so that they can stop their sending data. CSMA is an early MAC address based Ethernet protocol to verify that no other node is transmitting before sending data along early coaxial and twisted pair network, half duplex network. So it was later modified to include collision detection to terminate the transmission if a collision is detected. Okay. Like if you are trying to send data, suddenly you sense that there is a network jam, so you stop your sending data. The node senses to see if data is being transmitted. If no signal is detected, it will send data. If it senses a signal, it waits until the data has finished being sent. So other PC, other computer will stop sending data until network become free. If a collision is detected, collision means two computer has tried to send data. Now both have stopped. So the node stops send out a jamming signal to notify that a collision has occurred. So they will inform other two there is a collision. The node then wait a random amount of time to transmit again. Okay, on modern twisted pair Ethernet cable network, full duplex communication is possible. And so CS7 is less of an issue. So now twisted pair cable has been improved. So it has full duplex. Full duplex means sending data and receiving data on different paths. Okay.
Okay.
You can go through quickly.
Okay. Okay, sir, I'm done.
Okay.
Yes.
Then they introduce another technology, carrier sense multiple
Yes,
access,
sir.
collision avoidance. So this is the collision protocol used on wireless network. Here a node listen for transmission before sending data. When all the data has been received, the receiving node sends an acknowledgement that the data has been received. If the sender doesn't receive the acknowledgement, the sender start the process all over again. Okay, just go through.
Okay, sir. Okay. Okay. Okay, sir, I'm done.
Okay. Now see this one. This is basically twisted pair cable. This one is basically twisted pair cable, and this is coaxial cable. coaxial cable, this is basically network media, part of network media. Okay. So network media can be wire or wireless. So older coaxial cable could only send data in one direction at a time, half duplex, so were prone to collision. Modern twisted paired Ethernet cable can send data in both directions at the same time, full duplex, so are not as susceptible to collision. The twisted pair cable has no collision, but in coaxial there was a problem. But now we are not using coaxial cable in any network. Okay, this is only used for TV. Okay.
Yes, sir. Yes.
Now, most popular topology is star topology, which we are using right now. In this, basically, there is a central device. Okay, there is a central device through which we connect all computers. Alternatively referred to as a star network, star topology is one of the most common network setups. This is used everywhere, even at your home. Every home has star topology because everyone is connected with a central device that is called router or hub or switch. So in this arrangement, every node means computer connect to a central hub, switch or computer. The hub acting as a server and the peripheral devices are as client. So devices connected with the uh, hub are called client. Okay. All the data on the star topology passes through the central device before reaching the intended destination. In bus topology, data moved on cable, but here data will go to device and then device will send to other computer. Hub act as a junction to connect different nodes present in star network, and at the same time it manages and control whole of the network. Okay, got the point? So depending on which central device used, hub can act as a repeater
Yes, sir.
or signal booster. So hub also boosts the signal because signal become weaker over distance. This is called attenuation. Central device can also communicate with other hubs of different network. One hub can connect to another hub, so network expand. Unshielded twisted pair. UTP Ethernet cable is used to connect workstation to central node. As I have shown you, this is UTP cable. This is basically unshielded twisted pair cable, normally used in star topology, so that there is no collision. Okay, just go through this one.
Okay, sir. Okay, sir.
Okay. Now here you can see start topology arrangement. This is the hub which connect other computer. Again, see here hub. But right now we do not use hub, we use switch. Okay. Switch. Switch act as a hub because switch is more intelligent than hub. Hub is not an intelligent device. But problem is that when one computer send data to other, so it transmit to all computer. But switch does not do this one. Switch only transmit to that computer which has its data. Okay, for which data sent. Okay. You got the idea? Now, third topology is ring topology. Ring basically is a logical, not a physical. And this ring exists in a switch. Ring means first computer connected with the last computer. In ring topology, all the nodes are connected to each other in such a way that they make a closed loop. Ring established when first computer is connected to the last computer. So each workstation is connected to two other components on either side, and it communicates with these two adjacent neighbors. Data travel around the network in one direction. Sending and receiving of data take place by the help of token. So if any computer has to send data, it must have a token. Without token, it could not send. Like token passing. A token contain a piece of information which along with data is sent by the source computer. The computer which sending data is called source computer. This token then passes to next node, which checks if the signal is intended to it. If yes, it receives it and passes the empty to into networks. Otherwise, passes token along with the data to the next node. If any PC has to send data, it must have access to token. This process continues until the signal reaches its intended destination. But when one computer sends data, every computer receives the data. It checks whether data it is related to that or not. If address does not match, then it ignores. Send to next node. The node with token are the one only allowed to send data. Other node have to wait for an empty token to reach them. So this network is usually found in offices, school, and small buildings. But normally this kind of network does not use only star topology you will find in surrounding you. Okay, you can go through.
Yes, sir. Okay. Okay, sir. Sir, can I go for a question?
Yes, Ben.
Yes, sir. I'm back.
Okay. Have you gone through this one? Have you read?
Yes, sir. I'm at. I'll just do token passing again.
Okay, do that.
Yes, sir. I'm done. The
Okay.
time is over.
2, 3 minutes left. Here you can see
Okay. Okay.
the ring topology. So here you can see there is a switch. Okay. This is a switch, which maintain the ring. Okay. Ring mean last computer connect with the first computer. So this is the token ring. Moves in one direction. Okay. Got that?
Yeah. Okay.
This is token ring example. This network is just very rare. Okay. So take a picture of this. So enough for today.
Yes, sir. Enough, I guess.
So take a picture, then send to me so we can memorize where we left.
Okay, sir. I sent it.
Okay. Allah Hafiz.
Okay. Allah Hafiz, sir. Allah Hafiz.